Hello guys, and welcome to 3 Notes, Solving Systems of Linear Inequalities. Basically, this one here is very similar to solving regular, or graphing regular inequalities, only now 2 at a time. So if you recall how to graph regular inequalities, you need to graph from slope-intercept form, so up 1. Keeping in mind our rise over run, up 2 over 1, down 2 over 1. Now also, for inequalities, less than, greater than or equal to, you need to decide on the line type. So this is where you need to decide solid or dashed line. Why is that a dashed line again? Because of the less than. Also, shade in solutions. By picking a test point, we'll test out 0, 0 in this first case. So is 0 less than 2 times 0 plus 1? Well, 0 is less than 1. So that is where I want to shade. Okay, so a lot of times students forget about the shading. So this is just a brief little review, and you'll see why I'm doing this in a second. For the next one, graphing negative x minus 3 down 3, a negative 1 slope, solid line through all those, and we will test out 0, 0, and shake and bake. So is 0 less than or equal to negative 0 minus 3? 0 is not less than negative 3, that's false. So I don't want to shade that point. Instead, I want to shade everywhere else. So that's a quick little review. Now, solving systems of these inequalities. Now, if you're noticing, now we're going to be graphing 2 at once again, just like our graphing. So if you weren't getting graphing the first time, here's where it'll still come into play. Now, if you notice, these are the same equations from above. This is equation 1, and this was equation 2. And the only difference is with solving the system. Is you're still going to do the first 2, so graph 1 at a time. I'll just do it very quickly here since technically we already did it. Again, they're just the same exact equations from above. Now I will choose to shade or just kind of draw my dashes in one direction. If we graph our second equation, negative x minus 3 again, so including the shading, I highly recommend do them each 1 at a time. Solid line and shading. The only difference is now we want to know the intersection of both shaded regions, which is in pink. So identify the intersection. Those are your systems to the solution. Okay? Really easy as graphing both of them and then shading. So it can get kind of fun with the coloring. Okay? Now, different things these might look like. Identify inequality systems with no solutions. Again, graph them each just like you would before. So up 1, negative 3, 4. So down 3, 1, 2, 3, 1, 2, 3, 4. Solid line. 1, 2, 3, 1. Okay, we'll just connect both of those best we can. Where to shade, so do them all one at a time. What about the shading test? So do the shade test. Is 0 less than or equal to negative 3/4 times 0 plus 1? It is, so we will shade down. There's graph 1. Graph 2, 3x plus 4y was negative 16. For this one here, if you solve for y, equals negative 3x plus 16, sorry, is greater than. Okay, divide by 4. You have y is greater than negative 3/4 x plus 4. So now we are going up 4. 1, 2, 3, 4. And we actually have the same slope. Now, something might be going off in your head at this moment that we have the same slope. The lines are never going to intersect because they're parallel. And also, let's do our test point. So we still need to test 0, 0. So is 0 plus 0 greater than 16? That is false, so I will shade everywhere above. Now, so before we had the pink area where everything intersected. Now we have no intersection point, kind of a no man's land. No intersection point. Okay, so if you have a no man's land, okay, or you have nowhere that they intersect, in that case, there are simply no solutions. No areas intersect, and thus no solutions. Okay, most likely that'll be the case for parallel. Most likely. Okay, just another example or two here I want to look at. On this practice side, one key thing, don't forget, a lot of times students see these and they forget. X is greater than or equal to 2, that's a vertical line. Okay, so at 2, vertical line, solid, and I want everything greater than it, so it's going to be, actually, yeah, I want everything greater, so everything to the right. Now left, y is greater than 0, y is horizontal, so that's right at the origin. I want everything more than it, so our intersection, to be clear, would be right there, okay? At this point, I certainly don't mind if you answer the EQ now. Okay, 2, 3, and the word problem, I actually went through it ahead of time, so sorry if it's there, are going to be on the extra, in addition to the word problem down below. So answer the EQ now, and good stuff, guys.